Hey guys, let's look at, oh, bad word. Sorry, there's some profanity here on the Algebra 2. Look away, please, for a second. Go maybe look at the wall or something. Pretend you're at homeschool dance. Stare at the wall. Keep staring. Okay. She's pointing at you and wondering if you're going to ask her to dance. Okay. All right, now you can turn around. Okay. Yeah, bad word there. Complex fractions is what they're calling it, which is just a horrible thing to say. Anyway, the thing to remember about using or messing with these fractions in algebra is just do exactly the same thing you would do in any other fractions you did in 6th grade or whatever. So let's go ahead. This looks good the way it is because we know eventually if you divide a fraction by a fraction, you just flip it and multiply, right? So we're ready to do that as soon as we get this finished up here. So let's go ahead and stick this over a 1. And we know that the common denominator will be just a b, right? So we just go b here and b there. And we go ahead and go, okay, well I got a 1 plus xb over b. And that takes care of that. Okay, now we're ready to divide. All right, if you divide a by b, or excuse me, by a over b, that means you multiply by b over a. And you notice that these b's will cross out. And if I could get them to cross out, there we go, okay. And a lot of times these problems are contrived so that they'll do that. So here we go. And that is your final answer right there. There you go. Now let's move on to something slightly more interesting, okay? This is, if you want to pause it and copy this down, this is a doozy, all right? Okay. Well, again, you only have 2 steps ever on any of these fractions. We could go down 5 more levels if you wanted to, and they get complicated. Or excuse me. Oh, hold on. Bad word alert. Look away. Okay. Now you can look. It's safe now. Okay. You never have more than 2 steps on these. You find a common denominator. You flip and multiply. You can't find a common denominator, you flip and multiply. That's it. You just do it over and over until you're done. All right. So obviously we need to go down here and mess with this first. Okay. Which means we're going to have to go, okay, 1 over b plus, x over 1. All right. Well, obviously the common denominator is b, so that'll be a b down here and an xb. I always like to write these things over with. I'm just kind of, I don't know, I can see it better, but I'm just going to rewrite, and then I have 1 over 1 plus xb over b. My new fraction, okay? Now I'm at a point where I got a fraction divided by a fraction, so I just flip it and I multiply. So now I have a new one. I just leave the a the way it is, and if I just 1 over 1 times the reciprocal of that, that just means I have a plus b over 1 plus xb. There we go. All right. Not done yet because we want this to end up as once one fraction. So we have to figure out our common denominator, which is obviously 1 plus xb. So you multiply the bottom by 1 plus xb, and multiply the top by 1 plus xb. Okay, there you go. All right. And this turns into, I'll just go across here, 1 times a is a, and then xb times a is xba. Then I'll add my b, and then I stick this all over 1 plus xb, and that is my answer. And if you want to actually make up a bunch of values for a, b, and x and see if they work on this one and end up as the same on that one, you can check and see if you're right. Feel free. I won't be doing that anytime soon. Okay, let's try another one. Oh, hold on. Nice. Okay. All right, well look at that thing. Pause it if you want to and write it out. All right, well, let's take a look. And again, this is what we want to mess with right there. Let's fix that first. Obviously, our new fraction is going to, or our new denominator will have to be u. So 1 with the u in the denominator is going to be u over u, right? So we have this. Now, y over u plus 3 over, we'll call it u plus k over u. All right, now let's go ahead and divide our fraction, flip and multiply. So we end up with this, 3 over 1 times u over u plus k. All right, so now we have this, I'm going to carry that down, y over u plus 3 times u over u plus k. All right, now common denominator. We need that. So obviously over here we're going to have to multiply by u plus k. And over here we're going to have to multiply by a u. Now it gets interesting. Okay, so let's go yu plus yk, that takes care of that side, plus 3u squared. All of this is going to be over u times u plus k. I just flipped what was in parentheses there. Either way is fine. Okay, that is a simplified fraction because there's just one of them. Hey, let's go ahead and check our answers and plug something in. No? Okay, we won't have to. All right, let's move to something else. The second half of this is called, oh man, this is terrible. This word keeps popping up again and again. Just doesn't sound right. Complex numbers. How about, let's see, let me draw my extensive vocabulary. Good. Numbers. Okay. Well, we know what a complex number is. It's a real number plus an imaginary number. You know, an imaginary number, remember those is I, okay? The standard format that you write this in, you write the real number first and then the imaginary number second. That's just the normal way of writing this, okay? And all we're doing now is just messing with these and just piddling and doing things that you've done before millions of times on different kinds of problems. One thing you need to remember is this, though. And we can do it either way. You can either remember, I don't know if you guys recall this, but if you have two of these numbers with a negative square root multiplied together, what's going to actually end up happening is you're going to just go ahead and multiply these out. You're going to have a 6, of course. But you won't have a negative 6 underneath here. You'll have an opposite on the outside of the square root of 6. And the reason for that is that, you know, if you break up negative 2, that means you're doing negative 2 times, well, excuse me, let's try this again. It's going to be the square root of negative 1 times 2 times the square root of negative 1 times 3. Everybody see how I did that? Okay. Of course, this by definition is I, right? So you have the square root of 2, I, times, and of course, the square root of 3, I, times together, okay? These two multiply together to give you the square root of 6. Now, if you have I times I, that's I squared. If you remember our chart that goes down, you know that, I is the square root of negative 1. I squared is negative 1. So that's negative 1. This will be negative 1. So this will be a negative 1 times that, or just like that. And you do need, if you don't have your chart of I squared, I to the third, and I to the fourth, you need to get that out. You just, you know what, let me just do it one more time. I, of course, is just the square root of negative 1. I squared is the square root of negative 1 times the square root of negative 1, which is just negative 1. I to the third is I times I squared, or I times negative 1, or just negative I. And I to the fourth would be I squared times I squared, right? Or negative 1 times negative 1, or just 1. Okay. You need to know that. If you have a card out, get that out, or at least copy those down again, because we're going to need them. Because we're going to do things like this. Look at this expression. Pause if you need to and copy them. Okay. Well, we're going to have to simplify this thing. All right, so let's do several steps to make sure we get it nice and tidy and neat here. So we're going to go 4 first, okay? Remember, the definition of I to the third is negative I. All right? So remember back here, negative I. All right. Minus 2 times I to the fourth. Well, I to the fourth is just simply 1. So negative 2 times 1 is just negative 2. All right, and then we have plus 2 times the square root of negative 9. Now, if you probably remember that you can break this up into the square root of 9 times the square root of negative 1. Well, the square root of 9 is 3, and the square root of negative 1, by definition, is I. All right, plus, and remember you can either, do it the long way, or you can just remember 2 of these negatives under the radicals means you're going to pull out that outside, and then 3 times 3, we have the square root of 9, which is just 3. And anyway, anything times itself twice under a radical is just going to be that number anyhow. So, all right, we'll do one more little cleanup here. 4 times negative I will be negative 4i, and that'll be minus 2. and then 2 times 3i, will be 6i, and then plus a negative 3 is just negative 3. That's a real number. That's a real number. Together they add up to negative 5. This is an imaginary number. That's an imaginary number. Together they add up to 2i. And that is your standard form with your real number and your imaginary number right there. Okay. All righty. Let's take a look at one more. You've done this type of problem before, so pause if you need to copy. All right. You know what to do. If these were x's instead of i's, you would just do exactly the same thing you always do and just distribute, okay? So let's just go ahead and work on the 4 first and go over here to these two terms, okay? So 4 times 3 is 12. 4 times negative 2i is negative 8i, okay? Done. And now we have our positive 2i. So 2i times 3 is 6i. Here's where it gets tricky. 2i times negative 2i, well, we know first off that positive 2 times negative 2 is negative 4. Then we have I squared. Now by definition, I squared is negative 1. Okay, so there we go. We have our 12 here. We have our negative 4 times negative 1, which is just going to be 4. So that'll give us 16. All right. Then we have our imaginary part, which is negative 8i plus 6i, which is negative 2i. And there we go. Okay. All right, and that's how you multiply that kind of complex number together. Okay, let's try one more. Go ahead and pause it. Go ahead and pause and give yourself a shot at this. And see how you do. All right, I'm assuming you've paused it and then unpaused it. So we'll do 5i first. Then we'll go all the way down. So 5i times 4 is 20i. 5i times 3i will be 15. Well, you know what? We'll just call it I squared. Done. Negative 2 times 4 is negative 8. Negative 2 times 3i is negative 6i. All right? This is the one we need to piddle with, okay? If you remember, I squared is, by definition, negative 1, right? Okay. So this will be, we'll just go ahead and write a negative 1 instead there. All right? So this is going to be 15 times negative 1, or negative 15. I'll just go ahead and copy down the 20i. Minus 8 minus 6i. Okay, and this is a pretty simple part here. This is a pair of real numbers, and that adds up to negative 23. 20i minus 6i, 14i, and there you go. And that's dealing with that kind of complex number problem. Okay. All right, give the practice setup whirl. Go ahead and do A and pause it, and we'll come back together in just a minute. All right, I'm assuming you've paused it and you're back. Let's go ahead and make this over a 1, and we'll deal with this first. And let's see here. We know this is going to have to be a z, so I'll just go ahead and multiply by z here and z there. And then we'll call this whole new fraction set here b plus 1 over 1 plus 2mz over z. Okay. And of course, now we have a fraction divided by a fraction. So we just multiplied by the reciprocal. Well, if you want to imagine this as 1 over 1 and then divided by that, you can just multiply it by the reciprocal. So let's just do the entire thing over. B plus, then the reciprocal of this would just be z over 1 plus 2mz. All right? And of course, you want to read it like that. That's fine. Obviously, the common denominator is just 1 plus 2mz. And then we will just multiply the top here, 1 plus 2mz times that, and then 1 plus 2mz times 1. Piece of cake there. Okay, all we need to do now is just distribute this. So 1 times b is b. 2mz times b is, we'll just call it 2mzb plus that z. And all this goes over 1 plus 2mz. There we go. Simplified. Okay. All right. Pause it and try B. Okay, well, I hate ones with S's because my S's always look like 5s. I spend like 4 hours trying to do a problem because I don't recognize my own handwriting as a 5 instead of an S. But anyway, all right, that's a 5 over a 1. We know that the common denominator is a z, so we'll just call this 5z over z. all right? All right, so we got to your, I'm just going to rewrite this whole thing so we can visualize it. S over Z, not 5 over Z, plus 3 over 5Z plus 2S over Z. All right, and I'll just call this 3 over 1 up here and multiply by the reciprocal C over 5Z plus 2S, which will give me a new couple of fractions, S over Z plus a very fun, let's see here, 3Z over 5Z plus 2S. Okay. Woof! This is going to be fun, this common denominator. All right, that gets multiplied by Z. This gets multiplied by Z. Oops, got ahead of myself there. And this over here gets multiplied by 5Z plus 2S. Okay. And this also gets multiplied by 5Z plus 2S. All righty. So, at least you just have to write one denominator now, for heaven's sakes. I'm just going to keep it like it is. Z times 5Z plus 2S. But if you went ahead and distributed that for your answer, that's fine. In case yours looks different in the back of the book, just make sure that they didn't distribute or did distribute or whatever, and yours matches up. Okay, I'm just going to go ahead and put at the end of this plus 3Z squared, because that's easier. All right, now let me get to this. So 5Z times S is 5ZS. Yeesh. Okay, 2S times S is 2S squared. And that is your answer. There we go. All over one denominator. All right, pause it and try C. Okie doke, C here. I to the fourth power by definition is 1. All right, I to the third power is by definition negative I. Negative 3, we'll just leave it, okay? We know that this will be a negative 3 times a negative 5, which means we're going to be well, let's just do it together. This will be, we'll just pop it up here. We'll break this up into 3 times negative 1. And we'll break this up into 5 times negative 1, okay? All right? So this is kind of a kooky one. You're going to find these every once in a while in your book that you're going to go, what, huh? How did I get, I didn't quite understand what they did. On these islands, don't sweat it too much. You'll see what happens. But anyway, this is going to turn into the square root of 3 times I times the square root of 5 times I. And of course, i's multiplied together, I squared is by definition negative 1. And then this will be the square root of 15. Okay, so this is going to be negative 3 times negative 1, or just negative the square root of 15, like that. Okay. All right. Getting weird yet? Okay, so negative 5 times negative I is going to be positive 5I. Negative 3 times negative square root of 15 is going to be positive 3 square root of 15. All right. This is a real number, even though it's an irrational number. It's on the number line somewhere. So you're going to smush this in here with that one. So in the back of your book, it probably has something a little strange, but it'll probably look like something like this, where they've used parentheses to stick them together. That's the real number part. The imaginary number part is this, with the 5i. So that's probably what you're going to look like right there. If you need to do this and break it up and remind yourself that that's how it works and then negative, or you don't have to, you can just go, if both of those are negative, just go, there's a positive number underneath the radical, and it's going to have an opposite sign being multiplied on the outside. Okay, all right, pause it and try D. Okay, D, let's take 3 first. 3 across to 4 is 12. 3 to negative 5i is negative 15i. Done. All right, 5i times 4 is 20i. Here's the tricky part. Positive 5 times negative 5 is negative 25, yes. But I times I, by definition, is negative 1. All right, so let's get the reals first. There's a 12. There's the negative 25 times negative 1, which is just plus 25. So that'll be 37. The imaginary part are these two together, which will give you a total of 5i, and that is it. There you go. Real plus a imaginary, that's standard form. So, all right, have at it. Have a great day. See you guys later.